Hi guys. So today we're going to look at how to solve absolute value equations. So before we look at solving these, we just want to review graphing a little bit. We also want to look at how we can use graphing to help us solve equations. So we use graphing to help us find the solution to a system. Well, this is a very similar process here when we're trying to solve an equation. Any equation that you look at when we talk about solving, what we're really doing is we're saying, where does this function intersect this function? So I can actually solve this by graphing. So I'm going to graph the function absolute value of x minus 2. So if you remember, that means it has a vertex of 2, 0. Coming from the vertex, there's a slope of 1. So there is my x minus 2 absolute value graph. Well, I want to know where that intersects the line y equals 3. So I'm going to graph the line y equals 3. And you'll notice that it intersects in 2 places. The places where it intersects, those x values, are my solutions. So x equals 1 and x equals 5. Now we're going to look at how to do this algebraically here in a second, but the reason that it's important for you guys to understand the graphing idea, being able to visualize this will help you check for the reasonableness of your answers when we get to the more difficult questions. All right, so now let's look at B. Again, I'm going to start by graphing this equation on the left. That equation is going to have a vertex of 2, 3. It's going to open down, but it's still going to have that slope of 1. And the reason I said I like for you guys to look at this visually by graphing, I want to see where it intersects the line y equals 5. Well, the line y equals 5 is way up here. And those two things are never going to intersect each other. So since they're never going to intersect, this equation has no solution. Now we'll look at the reason why here in just a second. So in order to solve an absolute value equation, there's a couple, the properties that we talked about last class we need to consider, but really what we need to do is we really need to consider 2 cases, because the absolute value of 1 is 1, but the absolute value of negative 1 is also 1. So knowing that both those things are true means that I need to really set up 2 equations each time I solve an absolute value. So what I'm going to do for absolute values, I'm going to set up 2 separate equations. So the first step, though, whenever it comes to solving, is always, always, always to get the absolute value by itself first. So we can't do anything until we've done that first. All right, so make sure that that's our first step. Well, on A, that's already done. So once the absolute value is by itself, I'm going to set up 2 equations. Well, one of those equations is just x minus 3 equals 7. The other possible case, though, if whatever is inside the absolute value is negative, it's going to give me the same answer. Because like we said, the absolute value of 2 is 2, but the absolute value of negative 2 is also 2. So if we get that same solution inside the absolute value, that's just the negative version, it's also going to work for my equation. So my second equation here is going to be the entire function inside the parentheses negative, which means negative x plus 3 is going to equal 7. And now I'm just going to solve both of those equations. So I would get x equals 10, and then I would get negative x equals 4, so x equals negative 4. Now, I shouldn't have boxed that yet because there's one last step that we need to look at. And this step is going to be very important going forward for all of our functions. This is something that's going to come up in a lot of units, and it's something called an extraneous solution. So what that means is we follow our process, we solve our equation the same way we're used to solving it, but occasionally what's going to happen is we'll get an answer that when we take it and plug it back into our original, it doesn't actually work out. So we need to make sure that the solutions that we get are actually solutions. So let's start with this first one, for example. If I take 10 and actually plug it back into my original equation, 10 minus 3 is 7. The absolute value of 7 is 7. So that one does work. All right, so now let's take negative 4 and plug that in. Negative 4 minus 3 is negative 7, and the absolute value of negative 7 is 7. So this one works as well. So in this case, both of our answers are okay. But we always want to check in case we run into one of those extraneous solutions. All right, so now let's look at example B. So the absolute value is already by itself, but we want the absolute value to equal negative 5. Now, knowing a lot about absolute value will make these questions easier for you. The absolute value is going to equal a negative number. What we know about absolute value, it's just the number's distance away from 0. So the absolute value is never going to equal a negative number. So this is going to have no solution. Some other ways you can think about this. Okay, this graph, 3x plus 1, it's going to have a vertex somewhere over here. It's going to be opening up. If it's opening up and the vertex is up there, it is not going to ever intersect the line y equals negative 5. All right, it's just following those absolute properties. But we cannot make this decision about the negative on the other side until you have isolated the absolute value first. That's a very important first step. All right, so let's look at some other examples. Again, first step, we have to get the absolute value by itself. So the first thing I'm going to do is add 9. Now I'm going to split this up into my two equations. So one equation is just the same thing without the absolute value. The other equation is going to be the opposite signs of everything in the absolute value. I'm going to solve both of those. So that purple equation on the left, that would be 3x equals 12 and x equals 4. Then this other equation, I would get negative 3x equals 0, so x equals 0. Plug them both in. Now when you plug them in, if you want to plug them into the original, you can, or if you want to plug them back into the one when you've gotten that by itself, either of those is okay, but both of these should work out and give us solutions that are not extraneous. All right, so now let's look at something like D. So something like D, it's going to be the same type of process. The equation's just going to look a little bit different. So we're going to start this by writing our absolute values already isolated. So we'll go ahead and set up our equations. 2x plus 12 equals 4x is one equation. The other equation would be negative 2x minus 12 equals 4x. So let's go ahead and solve both of these. So I would get 12 equals 2x and x equals 6. Then over here on the right equation, negative 12 equals 6x, so x equals negative 2. Now before I box these, I'm going to check my answers. It's very important that we get in that habit. Just like I said, we're going to see some of these extraneous solutions coming up. So if I take 6 and I plug that in, all right, well that would give me 12 plus 12 is 24. The absolute value of 24 does equal 24. So 6 does work out. But look what happens when I plug in my other solution, negative 2. If I take negative 2 and I plug that in, 2 times negative 2 is negative 4. Negative 4 plus 12 is 8. But if I plug negative 2 in over here, I get negative 8. The absolute value of 8 is not negative 8. Okay, the absolute value of anything is never going to equal that negative number. So even though we did our work and we solved and we got x equals negative 2, x equals negative 2 is not actually a solution, it's extraneous. So our only solution to this equation would be x equals 6. Now again, we talked about thinking about what the graph looks like here. 2x plus 12, if I were to graph that, all right, the 2 could come out. This would be stretched and it would be shifted over. So my graph would look something like this. I want to know where this intersects the line y equals 4x. Well, y equals 4x would look something like that. And you'll see that if it really looks like that, there's only one intersection point. Okay, this graph is not going to intersect in another place. All right, so let's look at a few more examples. Same base. We're just going to do a couple different examples. But if you feel comfortable, go ahead and pause the video and try E. All right, so two cases. The absolute value was already isolated, so just drop the absolute value bars and solve. So in this case, I would get x equals negative 1. All right, then let's solve the other one. And then I'm going to change the signs. So negative 3x plus 1 equals 2x minus 2. So that would mean that 3 is equal to 5x and x is equal to 3/5. Take those values and plug them back in. Well, if I plug in 3/5, 6/5 minus 2 is a negative number. Absolute value is not going to equal a negative number. If I take -1 and I plug that in, well, -2 minus 2 is a negative number. Absolute value is not going to equal a negative number. So this is a case, again, where there would be no solution. And again, if you want to graph it and see what it looks like, okay, you've got your absolute value graph. Looks something like that. You've got the line 2x minus 2. The line 2x minus 2, it's going to have a steeper slope, and it's going to go outside my graph. So it'll be something like that, where it just misses. All right, so now we're going to look at an absolute value equal to an absolute value. So this is pretty similar to what we just did. We are still going to set up two cases. So one case, we just keep these positive. And then I'm going to solve that equation. Okay, that's going to give me one of my possible answers. Now, we also know what's inside the absolute value could be negative. Well, if I did it for both of these, let's say I did -x minus 8 equals -2x minus 1. Well, that's the exact same equation as what I already have. Everything's just multiplied by -1. Well, if it's the same equation, I don't need to write it again. So then another option is this equation on the left. Everything could be negative. And over here, everything could not be negative. That is a different equation. So we are also going to solve that one. So -x minus 8 equals 2x plus 1. The other case would be, what if the absolute value on the right on the inside was negative? So what if I made this x plus 8 and -2x minus 1? Well, that is actually the exact same equation as what's already listed. If I were to go and just multiply everything by -1 in that equation, I'm going to have the same thing that's already there. So even though we can kind of think of 4 different things that can happen, there's still really 2 equations here that we need to solve because those are the only cases that are created. So basically this equation on F, we're going to solve the exact same way we did for E. All right, so let's go ahead and just work this out. So let's solve for x. So I would get that x equals 7 over here. And then over here on the blue equation, I would add that, I would subtract. So -9 equals 3x. So x equals -3. Test both values, plug them both into the original. They do both work out. And I do have 2 solutions. All right, so now let's move on, try a couple more. All right, so another one, absolute value equal to absolute value. So let's set up our 2 cases. X plus 5 equals x plus 11. And then the case where the first one is opposite signs and the other one is not. All right. Solving both of those equations, subtract x from both sides. So I would get 0 is equal to 6. Well, 0 equals 6 doesn't happen. So there's no solutions coming from that part of my equation. Let's move on to the next one. If I subtract 11, add x, I get that x equals -8. Well, let's take that, plug it back in, and make sure it works. -8 plus 5 is -3. -8 plus 11 is 3. The absolute value of -3 is equal to the absolute value of 3. So that answer does work out. So there is one solution here. And again, thinking about the graphs, both of these have the same slope. They've both been shifted left. Since they have the same slope, they're only going to intersect in that one place. All right, on H, very similar again. Think about our different cases. Even though there's that number multiplied on the outside, it's not going to change the work that we're doing. We're still going to do 5x plus 12 equals 2 times 4x minus 1 as one case. And then we're going to do negative 5x minus 12 is equal to 2, 4x minus 1. And then just solve both of these cases. Check your solutions. So I get 3x equals 14. So x equals 14 over 3. Solve my equation over here. option, plug them both in, make sure they both work out. In this case, they both do, and neither one is extraneous. All right, so the next ones that we're going to look at are just a little bit trickier. They just kind of use some different ideas and make you think about absolute value a little bit more. So on this one, what we have is an absolute value inside of an absolute value. So what we're going to do is we're going to use what we know about absolute value. All right, so this first absolute value here, it is isolated. It's already by itself. So we're going to go ahead and split this into two equations. Well, one equation would be the absolute value of 2x plus 5 minus 3 equals 10, where we just drop the absolute value. The other equation would be opposite signs. So negative absolute value of 2x plus 5 plus 3 equals 10. All right, so let's go ahead and solve. Let's solve the one on the right first. So I would subtract 3. Okay, so now again, we have to get the absolute value by itself. And right now, it's not by itself. I need to multiply by that -1. So now, the absolute value is isolated. But remember, if absolute value is equal to a negative number, once you have it isolated, that's not going to have any solutions. So even though this broke off into a potential second equation, that second equation is not going to yield any actual answers. So we're not even going to solve that part out because absolute value is not going to equal a negative number. So let's continue on this equation over here. So absolute value of 2x plus 5 is equal to 13. And now I have another absolute value equation. So now from here, I'm going to break this up into its own two equations. Well, one of them will be 2x plus 5 equals 13. The other one, again, would be, if I change those signs, negative 2x minus 5 equals 13. Well, let's go ahead and solve the first one. 2x equals 8, so x equals 4. Let's go ahead and solve the red one. Negative 2x equals 18, so x equals -9. Take both those values, plug them both in. Neither of those answers is extraneous, so those are our two solutions. All right, the last one on here, it's not really particularly tricky. It's just a different variation, and it uses those properties that we listed at the very beginning. So just like with multiplication, one of the properties we said was if you have the absolute value of a over b, that I could rewrite that as the absolute value of a over the absolute value of b. So that means that this equation can be rewritten like this. Well, if I have something in this form, the easiest way to solve it is by cross-multiplying or by multiplying by what's on the bottom. So if I multiply by the absolute value of 3 minus x, then I'm left with the absolute value of x plus 1 equals 5 times the absolute value of 3 minus x. And this is just like the example that we did earlier that was example H. So again, set up our two equations. So we'll do one that's positive, and we'll do one where we've changed the signs. And we'll solve both of these. So solving the first one, so I get that x is equal to 7 over 3. Then we'll go ahead and finish this one up. So two possible answers. Check them both, plug them both in. All right, so those are my two solutions, and neither of those are extraneous. All right, so the last thing we're going to look at are applications and some word problems. Sorry about the bells today, guys. So let's go ahead and look at some examples. So when it comes to these questions, some of these you may be able to figure out without writing them as absolute value, but we still want to be able to come up with an absolute value equation that represents the situation. It's just an important strategy. It's something that'll come up on ACT. So we really just kind of want to see how to write these equations that model it. So it says the average temperature in Texas in July is 96 degrees. The actual temperature may be 10 degrees cooler or warmer, or knowing Texas is probably more than that. But what we're going to do is we're going to write an absolute value equation that we can use to solve for the maximum and minimum temperatures. So when we write absolute value equations, Negative does not matter, basically. So what we're going to do is we're going to do the temperature minus 96 because that's our average, that's our middle. We know that the difference between those has to equal 10. So that's how I would write my equation. Then solving it from there, I would do T minus 96 equals 10. So one temperature would be 106. I also would do negative T plus 96 equals 10. So negative T is negative 86, which means that T can also equal 86. So my minimum temperature is 86. My maximum temperature is 106. So setting something up in this form is going to be pretty important for us. All right, so just remember, this is our kind of our midpoint, and this is really the differential from that midpoint. This is going to come back up again when we do inequalities next class. All right, the next one's more of a modeling question, pretty similar to what we saw with some of those word problems on our graph days. So it says, Jim bounces a basketball to Dwight. He's holding the ball at a height of 4 feet, and then when he passes it, it bounces 3 feet away from him. Then Dwight is 2 feet from where the ball bounced. So we're writing an equation to model this. What I'm going to do basically is list the coordinates that I know. So I'm going to make my 0, 0 over here. We're going to make the 0, 0 where Jim is standing. So if Jim is holding the ball at a height of 4 feet, then, he's holding it at a height of, 4 feet. So he's holding it 4 feet above. He's going to pass it 3 feet away from him. So that's going to go at 3, 0. So that's the path the ball is traveling. So from 4 feet, it goes 3 feet away. Then it's going to bounce again to where Dwight is. Okay, we don't know the height that he's going to catch it. We do know how far away he is. So we know that it is 2 feet away from where the ball bounced, so that's going to be at 5. We do not know the height, and that's what we're solving for. So to write the equation of this graph, we know the vertex, we can figure out the slope. So the slope basically on this point right here, it went up 4 and over 3. Then it's x minus 3. And then we're trying to solve basically for whatever that height was. So if I take 5 and I plug that in for x, then I would get that y equals 8 over 3, which would be like 2 2/3 of a foot. So when we get these modeling type questions, what we really want to do in order to set this up, again, we want to try and write the equation of a graph that shows a situation. Then we want to solve for the piece that's missing on that equation. All right, so that's it for absolute value equations. We'll do something very similar when we do inequalities next class.